Hello everyone, welcome to Universal Group of Institutions, Bangalore. Today we will talk about plate tectonics theory and the diagram you are seeing right now. Like, why is India crashing into Asia? Plate tectonics hold this answer. So today we will talk about plate tectonics, and if I tell you that earlier India was a like 200 million years ago, India was a lonely island, near Antarctica, as you can see in the diagram. Today it is colliding with Asia, creating the Himalayas. Can you see the Himalayas making here? This is the plate, Indian plate, colliding with the Eurasian plate. Okay, and it is, see, the moment it will collide, the Himalayas are formed here. And you will be surprised to know that Himalayas are still rising by 1 centimeter per year. But how? Plate tectonics theory is not just a chapter, students. It's the reason Earth looks the way it is. Okay, and the phenomenons like earthquake happens. Okay, the recent earthquake in Delhi, Bihar, Ghaziabad, Himachal Pradesh, Bay of Bengal, these earthquakes are the earthquakes that happened in 2015. So why these earthquakes are there and why volcanic eruptions are more in the Pacific area, Pacific ring of fire, that is in the Pacific Ocean. So by the end of this particular video, you will master this particular topic that is important for UPSC, KPSC, UGC, NET and other competitive examinations. So there is a full playlist available for UPSC Geography or KSPS Geography. As you can see that we have covered how Earth crust and interior formed, how the continental drift theory was there, how earthquake was there. So this is our fourth and fifth video regarding plate tectonics theory, and in upcoming videos we will talk about the plate tectonics boundaries as well as the major and minor plates of the world. So stay tuned. Make sure you subscribe the channel, keep the notification bell on so that you can get the video first. Along with the geography, we have the political science, current affairs, science and tech, and many other subjects along with the history. Okay, so make sure you subscribe the channel. Okay, fine. So if you want to know more about earthquakes, I've explained that in this particular video. This description, in the description box, you will get the link of that. So today's topic would be the contents of this particular lecture would be the concept and hypothesis of plate tectonics, where we will talk the postulates of plate tectonics theory, overview of plate boundaries, divergent, convergent and transform plate boundaries, evidences of plate tectonics theory, the significance of plate tectonics. Okay, fine. So what exactly is plate tectonics? Okay, so first of all, the movements of these large sheets of rocks, or we can say plates that form the earth's surface. So basically it's like right now I'm sitting on a chair, I'm sitting on the we are on the earth, everybody is on the earth. Now I'm just saying that when that plate is moving, now you will say, sir, we are stationary. Okay, we are not moving at all, right? I agree. So these plates are inside the earth. Right now you might be here. So these plates are inside under the earth crust, around 60-100 kilometers deep, and these are very big plates, and those are moving at a very slow pace. That's why you don't feel. But when these two plates collide with each other, then we will feel the vibrations that result into earthquakes and volcanoes. Okay, this is how the plate tectonics works. So the term plate tectonics was first used by Tujo Wilson. He was from the University of Toronto, but the theory was first published by W.J. Morgan. He is W.J. Morgan, he is Tujo Wilson. So Morgan was from Princeton University. He published the plate tectonics theory in 1962, and the earlier was Alfred Wegener's theory. Okay, so plate tectonics theory is a scientific theory that describes the seven large plates, motion of the seven large plates, and the movement of large number of smaller plates of Earth lithosphere for the last hundreds of millions of years. So we will talk about these large plates and major and minor plates in some another lecture. Right now you should know that what are the seven large plates. North American plate, South American plate, African plate, Eurasian plate, Australian plate, Antarctic plate, and the one important plate, that is our Pacific plate. Okay, so this is how these are the 7 large plates of the world. When they moves, earthquakes, volcanoes, and various type of landforms formed. So, if I talk about the historical context, students, so he is Alfred Wegener. He gave the theory of continental drift theory. In that, he gave some evidences. He told us about the Pangaea and Panthalassa, and in the evidence of that, when some people asked him for the proof, he gave various evidences like fossil matches and continental jigsaw puzzle. So, and the only flaw of this person was that he could not describe the mechanism of the movement, like how exactly plate float on what, like plates are floating on what. Now we know that plates float on the asthenosphere, the layer between the mantle and the crust, asthenosphere, the semi-molten, semi-liquid. Okay, but he could not tell about asthenosphere at that time. So that's the only flaw of his theory. So if you want to know more about continental drift theory, you can refer to my video continental drift theory. It is available on this particular YouTube channel, or I will put the link in the description box for that. Okay, and in UPSC also this question was asked. See, in UPSC 2019 main GS1 discuss the evidences in support of continental drift theory. So these evidences are written here, as you can see: jigsaw fit continents, stratigraphic evidence, fossil evidence, placer deposits, and tellite deposits. Okay, and in UPSC 2020, what are the limitations of continental drift theory? How does the plate tectonic address them? This is the blend of this particular chapter and this particular chapter. Okay, so let's talk about the plate tectonics hypothesis. So this particular theory is based on two principal hypotheses. One is Arthur Holmes' current hypothesis, convection current hypothesis in 1927, and the second is concept of sea floor spreading advocated by Hess in 1962. Okay, that you have to remember. Now students, this particular theory, the plate tectonic hypothesis, as you can see, the first is the concept of sea floor spread. Let me talk about this first. This Arthur Holmes. Can you see the convection cells here? These currents are called convection currents. Okay. When in the mantle magma is rising, it becomes a low pressure, means it will rise above. Now as it is going up, the temperature is getting down, so density will increase. Now because of the high density, that magma will again go down. This particular process is called what? This particular process is called plate tectonics convection current hypothesis. Okay, remember that. Now second hypothesis was given by the Hess, sea floor spreading, the concept of sea floor spreading advocated by Hess. So sea floor spreading means, as you can see, the magma is rising up. Which type of boundary is this? So when the magma is rising above and the two plates are moving apart, that is called divergent plate boundary. Okay, divergent plate boundary. Now when the magma is coming out, students, don't you think it will instantly molten? Like it is the molten form. It will instantly get hardened. That magma will turn into lava, and the lava will turn into igneous rock instantly because of the low temperature in the water. So such type of ridges are called mid-oceanic ridges. The largest ridges in the world is mid-Atlantic ridges. Mid-Atlantic oceanic ridges, world's largest, remember that. So sea floor spreading, this particular concept was given by the Hess, and it became more evident that plate tectonics exist. Okay, fine. That is called our seafloor spreading. So Harry has proposed that new oceanic crust continuously forms at mid-oceanic ridges, causing the sea floor to spread outwards. As you can see in the animation, it is going outwards like this. So this particular process helps drive the movement of tectonic plates, linking directly to the broader framework of plate tectonics. So again, this convective current and sea floor spreading are the part of like tectonics hypothesis. These are the historical ones, latest one, and this one is the most provident, like most we can say that acceptable evidence of plate tectonic hypothesis is paleomagnetism. So paleomagnetism means study of Earth's ancient magnetic field logged in the rocks. That is what our paleomagnetism means. So this particular presentation, as you can see, these white color rocks are having reversed magnetic polarity, means these are having the present north and south. This will be having south north, this will be having north south, this will be having south north. It means right now this is our globe, okay, this is our north pole, this is our south pole. Earlier times we have found the evidence that earlier times these magnetic poles were reversed. Earlier this was the south pole and this is the north pole. So basically when the magma was rising, so it contained some magnetic materials. The moment they comes out and they froze down due to the low temperature of our earth's surface of the water. Now suppose that at that time this is the north pole, this is the south pole, so the rocks will be like this, okay, this is the north pole, this is the south pole. Now millions of years this polarity is getting reversed. Now north pole is this, south pole is this. So these rocks are assembled like this, okay, north south, south north, north south. Okay, are you getting the point? Paleomagnetism, we will talk about detail, don't worry. So understand right now the polarity was different at that time. So whenever the polarity was reversed, it is showing in the white. So this shows that sea floor spreading exists and plate tectonics exists. This is also the evidence we will talk further in the video. So postulates of plate tectonics, what exactly plate tectonics, that what are the postulates first? So postulates are the basic assumption, or we can say the fundamental foundational principles that underpin the plate tectonics. And postulates means it's a general word I'm describing, that whatever the postulates are there, so we will assume the basic assumption and the fundamental principles. Okay, so postulates means they will serve as a starting point, that universal fact everybody is agreed upon. So what are the postulates of plate tectonic theory? What are the modern plate tectonic theory which everybody is accepting? That first one is lithosphere. Okay, the earth's interior according to mechanical rigidity, means according to the latest plate tectonics, is that lithosphere is the rigid outer layer, that is the lithosphere. As you can see, this particular area is lithosphere. This is the crust and the part of upper mantle, like lithosphere thickness would be around 100 kilometer thickness, okay, and its density is less dense, okay, the material below, so it is floating over it. Okay, the lithosphere is floating over which layer? Asthenosphere. So asthenosphere is like a plastic upper mantle, or we can say semi-fluid, this particular semi-fluid layer. Above that layer, lithosphere is floating, and that is what our plate tectonics are. The third, the third layer is mesosphere. Okay, so top one was lithosphere. Okay, second one was our asthenosphere, upper mantle. Okay, mesosphere is lower mantle. Okay, that is called mesosphere. There is one more mesosphere in the atmospheric layers also. Don't confuse with that. That is also mesosphere. That is more rigid lower mantle. This is more rigid. So this is this particular. This is fully solid. This is liquid. This is solid. This is liquid, and this is again solid. Okay, hope you got my point. So outer core, inner core, These are the liquid, solid, liquid, solid. These are the 5 postulates. Remember that. So earlier, what we knew? Earlier we knew about the Sial, Sima and Nife. Sial is silicon aluminium, that is the crust. Sima is in metal, silicon and magnesium. Nife is nickel and ferrous, that is in the core. Okay, earlier this was the classification, but with the new postulates, these are the 5 layers. Latest with the latest technology we have found out: lithosphere, asthenosphere, mesosphere, outer core, inner core. Okay, so this particular theory rejecting this classification. We know this particular theory, this Sial-Sima classification, in this one, like Earth crust is not strictly separated into these 3 only: Sial, Sima and Nife. Okay, so this is why plate tectonics is rejecting Sial, Sima classification. Fine. So what is lithosphere? Lithosphere can be, this is the outer rigid layer outside. So this particular plate can be classified into continental plate also as well as oceanic plate also. So this particular, in this particular diagram, let me show you, this is our oceanic plate and this is our continent. When two continents are colliding, that is called our continental plates. So this person La Pichon, he divided the earth into 7 major and 9 minor plates, as you can see here. So we will talk about this in the next video, so stay tuned for that. Okay, as well as like this plate boundary, first one is divergent boundary. When 2 plates are moving apart, that is called divergent boundary. And what will happen? This magma will come out in divergent plate boundary. So something is forming, right? That's why it is called constructive plate boundary. In second one, convergent plate boundary, subduction is happening. In this, ridges will be formed because of the magma coming out. In this one, trenches will be formed. Okay, because one plate is going down. One plate is, which plate? High dense will go down and low dense will go up. This is how our Himalayas is also formed, and trenches will only form in the oceanic boundary. Remember that thing also. Okay, like here no trenches will be formed, fold mountains will be formed. Third one is transform. So something is destructive, something is destroying, that's why it is called destructive boundary. Okay, this is our transform boundary. Transform, when 2 plates are moving like this, when 2 plates are colliding, it is sliding past, that is called our transform plate boundary. Okay, yeah. So students, universal group is which is conducting the case mainstay series, started already from the 17th February. In this we are providing you 16 tests. Okay, and the offer price is only 3.99. In that test you will get 4 essays, full test, 4 essay test, 4 full length GS test, and 8 sectional tests: GS2, GS22, GS32, and 2 for GS4, like that. Okay, so you can have the timetable here. It is the schedule. So you can visit our website universalinstitutions.com, or you can just visit our offline center. It is in Vijayanagar, Bangalore. Okay, so and along with that, students, universal group, it's also a college where we have the integrated course: PUC, BSc, BCom, BA, and along with that, we mentor students for the UPSC and KS examinations also. So admission is open for that 2025 and 26. And if you if you provide them the code HIMA 007, then you will get the discount. Okay, that how you will know that you are coming from the video. Fine. See, thank you. Now, so past UPSC questions, UPSC 2020, what are the limitations of continental drift theory? How does plate tectonics address them? And UPSC 2020 again was asked, discuss the evidence supporting plate tectonics theory. So basically it is asking for the evidences. That's why there are 5 evidences to plate tectonics. First one is earthquakes and volcanoes. Second is PolarWandering. Third is magnetic reversal and seafloor spreading, and the fourth is ocean drilling, and fifth is hot spots. So these are the evidence for plate tectonics. So the main evidence, these are the main evidence. First, let's talk about the earthquakes and volcanoes. So earthquakes and volcanoes don't occur randomly, throughout the world, but occur in limited belts, as you can see. So largest active belt in the world is around the Pacific Ocean. Okay, so Pacific Ocean, as you can see, this is our Pacific Ocean, and horseshoe. This particular ring is called as Pacific Ring of Fire. Pacific Rim also and ring also, both are same thing. And in examination, question was asked that which of the following is called as the horseshoe, horseshoe like formation. That was also the Pacific Ring of Fire. Okay, so 90% of the world's earthquake occurs in this particular, and the reason is simple, because of convergent boundaries. Because of convergent boundaries, we have lot of earthquakes and volcanoes occurring here. Okay, fine. Second evidence is magnetic reversal. We have already talked about the paleomagnetism, that our earth is behaving like a magnet. This is today's north pole, south pole, but earlier what was there? Earlier this was the north, this was the south pole, this was the north pole. So this reverse polarity exists in the rocks, as you can see in the rocks. Okay, fine. So paleomagnetism already done, magnetic reversal and seed floor spreading already done, this concept. Second is polar wandering. So the migration of magnetic poles over Earth's surface through geological time is called as polar wandering. Okay, so as you can see that this apparent polar wandering, this is what it tells. It tells that it traces the movement of continents relative to Earth's magnetic poles over geological times. That is what APWP is partially is there, and this MA we are seeing here, MA, this indicates the approximate position of the magnetic poles. Okay, the position of magnetic poles at different times or millions years ago. Okay, and this particular drifting, as you can see, this alignment support the theory of continental drift. So basically Alfred Wegener was right, students, but he could not prove. Now we have the technology to prove it. Okay, paleomagnetism. Third one, the ocean deep drilling. When we sent the Glomar Challenger down to the sea here, so we found it. This Challenger retrieved rock sample showcasing the crust was younger, closer to the ridge, and progressively older further away. Also, the thickness. Suppose that we are having a ridge here. So this particular challenger found out that the layers near the ridges is thinner. It was thinner. As we move away, it is getting thicker and thicker. Okay, so that was also the evidence of plate tectonics. This is also a joint oceanographic institution for deep earth sampling. In this particular mission, the various universities participated to explore the geology beneath the earth's ocean floor. Okay, so this particular ship is used by scientists at hundreds of universities around the world. Okay, fine. And the next evidence is hotspot. The volcanic hotspot is an area. This particular hotspot is an area from where, this is the mantle, from where the heat rises as a thermal plumb from the depth deep in the earth. And what happens in this particular hotspot? High heat and lower pressure, at the base of lithosphere facilitate melting of rocks. What happens in this hotspot? Lot of heat is there. Because of this heat, the rocks above it is getting melted. Okay? Now this particular melting is called magma. This is how the magma forms. Okay, and the subduction, then convergent boundaries adding to this magma. But how magma formed? Magma is formed by those. Okay, fine. And this particular magma rises through cracks, erupts to form volcanoes as the tectonic moves. So this magma is coming out now. Okay, this magma is coming out, and this will result in the chain of the volcanoes like Hawaii Mauna Loa, Walua and Lohi. This is the hot spot. This is the Hawaiian hot spot. This is the Mental Plum, and these are the chain of volcanoes. Okay, this is the evidence of plate tectonics. So basically, as you can see that these are the evidences of plate tectonics, and like why we need this plate tectonics. What is the significance of plate tectonics? So as you can see that how mountain ranges are formed today. By various collisions, we will get to know about the plate tectonics. Like plate tectonics drives the formation. They formed the geological features like Himalayas and Alps mountain, etc. Mid-Atlantic ridges, the trenches, all volcanic arcs are created by plate tectonics movements only. Okay. Now, this economical viable, this copper, uranium, these are the important rare earth minerals are also found near plate boundaries only. So when we will know about the plate boundaries, we will have the access to these minerals also. Thirdly, it explains the distribution of earthquakes and volcanoes, tsunamis. As you can see, I told you about the Pacific Ring of Fire. So when we will know where are the plates, we will know where the earthquake, volcanoes, tsunamis will be. Okay. Along with that, when the volcano is erupting, we will know that CO2, when volcano is erupting, lot of CO2 is also getting released. So like it's like the nature is contributing in the global warming. It happens, but we are contributing more. Nature was doing from the long time. We cannot blame nature. Fine. Yeah. Secondly, when two convergent boundaries are colliding like this, so subduction zone will happen, and this subduction zone will, it will recycle. See, when the plates are moving down, magma is getting pressurized and the volcano is coming out. So our carbon is getting, our minerals are getting recycled. That's what we can say. And if anybody asks you that which one is older, continental crust or oceanic crust, answer is younger is oceanic crust, because continental crust generally don't go subduction process. Oceanic crust goes. Okay, and also the very important thing is that plate tectonics can also provide us insights into planetary evolution. Okay, so we can know about our Earth also and other planets also. Okay, and the recent theory is regarding plate tectonics is that this is our Madagascar, students. This is our Madagascar, and this is the eastern part of Africa, that is getting the eastern part. This is the eastern part. The eastern part of Africa is drifting towards India. This is also due to plate tectonics. Okay, so this is the comparison between continental drift, seed for spreading, and plate tectonics. You can pause the video, or we can share the PDF with you on the Telegram channel VJE Bengaluru. Make sure you join that channel. Okay, and this is the question for you homework, or you can say you can write the answer in the comment box. Okay, please read it. It's regarding plate tectonics only. Whatever we have done so far, it's regarding that only. Okay, so hint I'm giving you here. Now you can answer whether the answer is A, B, C or D. Okay, so that's all for today, students. That's the plate tectonics theory along with the evidences. In next, we will talk about the plate boundaries along with the major and minor plates of the world also. So stay tuned, subscribe the channel and keep smiling. See you in the next one.